Hello guys. Okay. Nah, actually. Hello guys. In this video, I will be tackling this integration question, and I saw it on an Instagram page called Integrals Every Day, and let's do it. Okay. So the question is this, where it's an infinite rooting problem. I think, yeah, square rooting problem. And so let's just focus on the thing we're integrating, f of x. We'll call this whole infinite root f of x, and let's just simplify f of x as much as we can before we tackle this. So instead of root, I'll write everything to the power of 1/2. So I'll start with one big bracket here, x to the fourth, x to the fifth, dot dot dot, 1/2, 1/2, 1/2, and then 1/2 again. Let me just double check. Yep, okay. And then when you simplify this, you get x 3 over 2 times this is that right? Yeah. And then once you simplify again, you get this. Sorry, that's a 5. To the power of 1 over 8, and then simplifying it again, you get x to the power of 3 over 2 multiplied by x to the power of 4 over 4. And I'm going to leave it unsimplified just so you guys can see the pattern. 5 over 8 times x to the power of 6 over 9. Wait, that's sorry, not 9. 16 times x to the power of 7 over 32. And it just keeps following this same pattern where my power is in this sequence. 4 over 4. It's not 5. 5, 5 over 8. 6 over 16. 7 over 32. And the general form is n plus 2 over 2 to the n. And because because of the rule of exponents, we can add these numbers up, and so it becomes 3 over 2 plus 4 over 4 plus 5 over 8 plus 6 over 16 plus 7 over 32 plus 8 over 64 dot dot dot. And we can simplify this as the series starting from 1 of n plus 2 over 2 to the n. And so my integral can be rewritten as the integral of my series of n plus 2 over 2 to the n starting from 1 to infinity. So, oh wait, sorry. X to the power of n equals 1 all the way to infinity of n plus 2 over 2 to the n dx. And let me just simplify this expression here. So let me start with the infinite series as the power. So let let me just break up into separate fractions. And then this here is a geometric series, specifically this one here. And then you can simplify this as 1 over 2 over 1 minus 1 over 2, which is equal to 2 times 1. So plus 2. So 2 times 1 is 2. And then this series here will need a little bit more work. So I'll call this S1. And then I'll work it out in a separate page. Okay, so we can see that it sort of looks like a geometric series. Geometric. So it kind of looks like a geometric series. The only thing that is different is that I also have an n on the numerator, making the terms that I'm adding up slightly different. So if I just rewrote this, if I wrote the first two terms, I'll get 1 over 2 plus 2 over 4 plus 3 over 8 plus plus 4 over 16 plus 5 over 32, so on and so forth. And then what I can do is S1 is also equal to 1/2 plus 1 over 4 plus 1 over 4. Just splitting this term up so that I get a kind of sort of geometric series within my original series, plus 1 over 8 plus 2 over 8, right? Just splitting this term into that, plus 1 over 16 plus 3 over 16 plus 1, sorry, I know I did that already, 1 over 32 plus 4 over 32, and then dot dot dot. And then because the order of addition wouldn't matter in this case, I could say that my series is 1/2 plus 1 over 4 plus 1 over 8 plus 1 over 16, adding up each first term in my bracket, so I get a geometric series 1 over 2 to the n dot 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 plus, and then the remainder, which will be 1 over 4 plus 2 over 8 plus 3 over 16 plus 4 over 32 dot dot dot. And notice how so if I label this S1, notice how there's a similarity between S1 and the second second part of my series here. So notice how this is this is exactly 1/2 of S of 1. S of 1? S sub 1. Because if I divide each term by 2, I get 1 over 4. 2 over 4 becomes 2 over 8. 3 over 8 becomes 3 over 16. 4 over 16 becomes 4 over 32. And so I could just simplify this to be 1/2 over 1/2, which is 1. So I get S1 is equal to 1 plus 1/2 of S1. And then what I can do is rearrange for S of 1. And I get S of 1 is equal to 2. Okay. And so going back, I get S1 is equal to 2, so I get 2 plus 2, and this is 4. So this is all of my infinite series, n plus 2 over 2 to the n. This is equal to 4. And so, again, another layer. I have this integral, which I'll call I, which was the integral of, not e, sorry, x to the this series here, and this this series converges to 4, and then you're just left with 1 over 5 x to the power 5 plus c. Thanks for watching. It was a good challenging question and I enjoyed it. Okay, upon editing, I didn't even realize that these numbers here, it's a little ambiguous, but it could also just be the nth root instead of being the power of the x. So what I mean is that instead of the square root of x cubed times the square root of x to the power 4 times the square root of x to the power 5 dot dot dot, it could just be the square root times the square root of x times the cube root of x times the fourth root of x times the fifth root dot dot dot. And how that changes things is that my function or my integrand is no longer x cubed x 4x to the power 5 dot 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 1 half 1 half 1 half 1 2 and 1 more. It's no longer this. It's x x 1 over 5, I think, 1 over 4, 1 over 3, and then 1 over 2. Let me just check. 1 2 3 1 2 3. Yeah, okay. So it becomes this now. Oh yeah, and the dot dot dot, and that kind of changes things up. So in the case where it is supposed to be like the nth root, which looking back at it now, I don't know how I didn't notice, but it's quite obvious that it is attached to the radical sign or the square root sign. So we'll do that now. So again, f of x, right, is equal to this, and then just simplifying this down, this becomes x to the power 1 half times let's see, x x dot 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 power 1 over 5 1 over 4. That's a lot of brackets. 1 over 6, I think. Yep. And then this becomes x to the power of 1 over 2 times x to the 1 over 6 times x dot 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 1 over 5 1 over 24, and then this becomes 1 over 2 1 over 6 x over 1 over 24. The dot dot dot, let me just write out one more term. So 5 times 24 is 120. And then what the denominators are is that it'll be 1 over, let's see, so before I times it by, or I divided by 2, and then I divided by 3. So divide by 3, divide by 4, divide by 5, and then this one here will be dividing by 6. So 720. And then noticing that these numbers are exactly the, I guess, not constant, the successive terms of the factorial. So this is 1 over 2 factorial, x 1 over 3 factorial, x 1 over 4 factorial, x over 1 over 5 factorial times x over 1 over 6 factorial, and so on. And the general form is x 1 over n factorial for the nth term, or the nth product, I guess, in that infinite product. Okay, and then using this here, I'll label this result star. Where does my cursor go? Yeah. So star again, this becomes x 1 over 2, or actually 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial plus 1 over 6 factorial, so on and so forth. And this is my, I guess, indice. So let me label this I, right? I want to find out what my indice will converge to. So this is the infinite sum from n is equal to 2 all the way up to infinity of 1 over n factorial. Right? And just a side note, e to the x, right? This function, e to the x, can also be represented by its Taylor series, starting from 0, going all the way to infinity of 1 over n factorial. And what that means is that 1 over 0 factorial, or actually I should say e to the first power, wait, sorry, my bad, that is a lie. The Taylor series expansion for e to the x is x to the n over n factorial, and so e to the first power is this here, 1 to the power of n over n factorial, for n being positive integers, so this just simplifies to 1 over n factorial. And then so you get a little bit of intuition on what this is 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial dot dot dot. And so if we notice that this here is our indice, I, right? It's right here. All of this is I. And then this, well, 1 over 0 factorial. 0 factorial is just 1. So this just becomes 1. And 1 over 1 factorial is also 1. So E can also be simplified to E is equal to 2 plus I. And so just rearranging for I, E minus 2. Okay. And so my integrand now, I can simplify this yet again and say that f of x is just equal to x to the power of e minus 2, and then my integral is just x to the power of e minus 2 dx. And then, well, x to the any power except for minus 1, you can just integrate via the power rule. It doesn't matter what this looks like, this is still a number. And so as long as that is not minus 1, it becomes 1 over e plus minus 1 times x to the power of e minus 1 plus c. Let me actually simplify a little bit more. Plus c, and there you go. That is your answer, opposed to what it was before. What was the answer before? I think it was 1 over 5, x over 5 to the power of 5 plus c. So depending on what the notation is, it's probably gonna be like the nth root instead of the power of the x. If it was the power of the x, it would give you this answer. If it was the nth root, it would be this answer here. So just depending on, you know, what it is, what you're interpreting the integrand as, you get different answers. And so here are the two separate answers. Okay, that was probably a lot. of information. So you can take a break, and here is a video.
Are you too broke to buy a P90? Do you own a katana collection? Did you like bunny hopping with a P90 in combat arms? Then fear not, the MP9 is for you.
That chinko lame, that chinko bitch, that chinko pussy. We got Henny, we got Shanks, we got Cookie. I put so much pussy, I might switch the pussy. The bitch is Asian and I call her for some suki. But this is a Roma, all up on the sofa. If he force me, I'ma send out by the Yoda. Leave him, fuck me, bitch, come over. The big pussy X, I can get it for some closure. I'm talking big brinks, I'm talking big bread, I'm talking big money, dummy on his big head. This pussy lucky, that little bitty don't play with lead. But when I'm rich, spend that frank, finna get him dead. Or I might DIY that shit instead. In a Benz truck, blick, tuck, like a fucking fed. Bitch, I'm all ears, I ain't hear what you say, yeah. Pussy think it's sweet, think it's soft, took it bread. Told you open up, but I ain't talking about them legs. I don't want no sex, I want that top. Everybody think it's soft till I let this K pop. Everybody filming me, but I'll show you it's not a prop. That's my whore, she a slut, she a bump. She gon' soak it up and suck it up just like a mop. The bitch ain't got bikini bottoms on, I feel like Bob. You still playing sweet, my life changed, we can't swap.
That dog tag. Dog tag, dog tag. 50k. That's not the max.